Hello, everyone, and thank you for joining me today. I'm excited to share a concise analysis of COVID-19 vaccination outcomes in Chicago, placed in the context of national case trends. Over the next few minutes, I'll cover the motivation, the goal, the data collection, its challenges, cleaning and transformation steps, the database schema design, and finally, the key queries and the insights that were derived from this project. I have all of this also laid out in the presentation if you would like to go over that. It covers the same information that I will be sharing with you right now. So, my primary motivation was to quantify the real-world impact of vaccination across different age groups in a major urban center. I wanted to compare those results against aggregated U.S. trends, specifically to measure hospitalization per death rates measure hospitalization and death rates per 1,000 people in unvaccinated, vaccinated, and boosted cohorts in Chicago. I also wanted to observe how Chicago's outcomes stack up against national case rates normalized per 100,000 population. This analysis supports policymakers, public health officials, and community organizations in understanding vaccine efficacy and guiding outreach efforts. I relied primarily on two publicly available data sources. The first one was the City of Chicago Outcome CSV, which contained weekly counts and rates of hospitalizations and deaths by vaccination status and age group. Next, I used the New York Times US COVID data. This was a cumulative daily case and death counts for the entire US. Challenges encountered along the way were Chicago data was in the long form, mixing rates and counts for three outcomes across multiple age groups. The date formats varied. Chicago's weekend dates versus New York Times date strings required harmonization. Some early weeks lacked valid age group breakdowns, and population denominators had to be sourced per 100,000 calculations. To prepare the data for SQL, I needed to create two pivot tables for Chicago, one for rates and one for raw counts, indexing by weekend and flattening the multi-index columns into descriptive names, like deaths, vaccinated rate. Along with that, I also had to flatten and rename columns to avoid SQL identifier conflicts. I needed to do date normalization, population normalization, as well as merging. There were three relational databases that were created. The first one was the Weekly Outcomes Chicago. This stores rates and counts for cases, hospitalizations, and deaths across each vaccination status. Next database that was created was the Age Group Breakdown Chicago database. This captures the rate breakdown by age group, and it was linked via weekend foreign key. And finally, the last database that was created was the Weekly Cases US, which holds weekly new cases and cases per 100,000 for the US population. The final SQL queries answered the following questions. So what is the vaccination impact in Chicago? The first query that I used ended up revealing that boosted cohorts experienced consistently lower death rates by as much as 70% in the January peak. The next SQL analysis that I did was for age group analysis. I was able to observe that older age groups saw the greatest relative reduction in hospitalization rates when they were vaccinated. Next was the national case trends SQL query. And finally, this contextualized Chicago's outcomes within the US and wave patterns, showing that Chicago's peak aligned closely with the national surges. So, finally, this was all to confirm the robustness of Chicago's data pipelines. So thank you for your time. I appreciate you watching. Hope you have a great afternoon, and if you have any questions, feel free to let me know. Have a great one. Goodbye.